Hello everybody, this is Miss Braden. I'm doing a tutorial right now on one of the skills that is part of your assignment right here called Construct Linear and Exponential Functions. All of these skills have IXL tutorials, so if you are having difficulty with them, you can always turn to the tutorial and the example, read with an example, if that is the case. There is one of these that does not have a video tutorial, and that is this one right here. Write exponential functions from word problems. So I will be doing an example of one of these in this video. That is the primary goal of this video. I will say that if you do get stuck on that one, I highly suggest that you go and make sure that you did this one first. That's why I put these in order. I put these in order roughly how you should do them. So this is the one I intended you to do first. It is a little easier because you have a table as opposed to a word problem where you have to determine what the values mean and what to do with them. This one is a little different because you do have to determine whether it is a linear or exponential function. And that's what this video right here is really helpful for. So just go ahead and watch that video or learn with an example. That is also helpful too, right there. Learn with an example as always. Let's go back to this one right here. Write exponential functions using from word problems. I actually picked this one. This is the one I'm going to do for you. So let's go to my little whiteboard and get to it. So here's our problem. You always need to read the problem all the way through, understand what the purpose is, understand what the meaning of these values is and what to do with them. So Martha just took 50 milliliters of medication. She read online that the amount of medication remaining in her body will decrease by a factor of 1/5 each hour. We want to write an exponential equation in this form right here. Y equals A times B to the X power in order to model the amount of medication, which is what Y represents, remaining in Martha's body after X hours. Okay, so Y is your, what we call dependent variable. Y, the amount of medication in her body, depends on X, the hours. So X is your independent variable. Y depends on X. So first of all, we are supposed to write this equation in this form right here. And you might be like, I've never seen that before. Why are you giving this to us, Miss Braden? I've never seen that before. Well, you actually have. You've just seen it using function notation in the following form. F of n equals f of 0 times r to the n power. Okay? Now remember, f of 0 is just the 0 term. It is the value of the function f when the input is 0. So the way that they've written this general formula is like so. To the x. All right, and this is exactly the same thing. We're just using function notation, and we're used to using r for common ratio. So if you need this listed out for you, f of 0 is actually A, r is B, and f of n is y. All right? That should help clear up some of the confusion you may have been having about these two skills that I gave you. Let's move on to the method you're going to use for writing this equation. There is a sort of more quick and procedural way of finding out what the common ratio or growth factor is for a situation like this, but we're going to rely on our understanding of how to calculate common ratio for now. Going to get rid of this. So, like I tell you pretty much all the time, if you don't know where to start, please start by making a table. And actually, let me just note that we do have 1 point here. If we do start making our table, we have 1 point, and that is the point when x equals 0, which is 30. So because when we're at 0 hours, we are at a concentration of, not concentration, but a volume of 30 milliliters. All right, and now we need, basically we're done with finding A, right? That would be your f of 0, which is going to be, they're calling this A in their general formula. A is 30. Now all we need is B. That's it. We just need B. There's numerous ways of doing this, but like I said, we're going to rely on our skills with making tables and extending sequences, and then the way that we calculate common ratio from that. Okay, so we now know, in order to find how much there is at 1 hour, we want to take the amount at 0 hours, 30, and then we need to subtract 1/5 of 30. So you do that by just multiplying 30 by 1/5, and then subtracting that from 30, the initial amount. All right. 30 times 1/5 is the same as 30 divided by 5. Hopefully you knew that. And that's the same as 6. So 30 minus 6, 24. And that will go right here. 24 milliliters after 1 hour. This makes sense, right? Because we're decreasing. The amount of medicine in her bloodstream is decreasing. And it's not decreasing like super rapidly. It's decreasing by a little bit. Specifically 1/5. Decreasing by 1/5 every hour. Now that you have that, you can calculate R. Or in this case, they call it B. Let's say B equals, you take any term in the sequence, or we could say like any output, and then divide by the previous output. So 24 divided by 30, and let's just practice simplifying fractions here. Is there a number? Clearly these are both divisible by 2 because they're both even numbers, but I can think of a bigger number that we can use to factor these down. I'd say 6. Okay, 24 divided by 6 is 4, and 30 divided by 6 is 5, so B equals 4/5. We could show that here. Multiply by 4/5. Okay. Now you have B, now you have A. Let's just go over here and write that. A equals 30, B equals 4/5. Using the equation right here, a times b to the x, you just are going to substitute these things in. Y equals 30 times 4/5 to the x power. Whew, all right, that is your equation. Probably the biggest part of doing this problem. Now, there's one more thing we have to do here, and that is calculate how much medicine is in her bloodstream after 6 hours. So if you were to extend this table that I wrote right here, there's some numbers that would go in between, and then we want to know what it is at 6 hours. So what is y when x equals 6? Okay, let's take this and say x equals 6. What is y? Y equals 30 times 4/5 to the 6th power. I'm going to grab my little calculator here. I have taught you guys how to write exponents, how to plug use exponent buttons on some of the calculators in my classroom. And that is with this little caret button right here in red. On a scientific calculator, that's what it looks like. You can use that button on your keyboard. It shares the key with the number 6. You have to use Shift 6 to use that key if you want to do that in many math applications. So it's on this calculator too. What was our purpose here? We wanted to raise 4/5 to the 6th power. I don't know how to do that in my head. I could write it out. Okay, that's a messy decimal number. I'm going to assume that it's going to want us to give this as a decimal number. So 7.86432. What does the problem want us to do as far as rounding? This is asking for the nearest milliliter. Important detail here. It wants the nearest milliliter. So we need to round to the nearest milliliter. That would be 7.8. We need to round up to the first one, to the ones place. So that would give you 8 in the end. So y squiggly equal sign 8 milliliters. Okay. Do that in green. Let's see if I did this right. Okay. Here's my function. Here's my equation. Here's the amount of medicine after 6 hours. So going over here, IXL has this nice little button right here that helps you with doing exponents. So what did we have? We had 30 times. They also have this nice little fraction button here. 4/5, close parentheses, exponent, x milliliters was 8. We rounded up to 8. Let's see if that was right. Awesome, we got it right. And I'm at a smart score of 66, but I gotta keep going till I get to 80. I hope that was helpful. If you have any questions, don't forget that you can come to my office hours. And I wish you luck with your homework. Thank you.